Welcome everyone. Today we are going to look into the chapter number 14, what are biomolecules? Now the name itself suggests that the molecules that are present in our environment. So they are carbohydrates, proteins, lipids, nucleic acids. Let's see them in detail. Biomolecules that are useful in your day-to-day life. You can see over here we have carbohydrates right present in Maggi, your grains, bread, potatoes, proteins, right, includes the almonds, eggs, chickpeas, fish, butter, walnuts, broccoli, and so many pulses, meat. Even your rubber is available from the rubber trees and so many things that are available, right, as your biomolecules useful in your day-to-day life. What is carbohydrate? A carbohydrate is a biomolecule consisting of carbon, hydrogen, and oxygen atoms, usually with a hydrogen oxygen atom ratio of 2 is to 1. The sources of carbohydrates are bread, spaghetti, wheat, flour, and so on. Carbohydrate is basically classified into two types: simple carbohydrates and complex carbohydrates. Simple carbohydrates are again classified into two types, that are monosaccharides and disaccharides. The examples of monosaccharides are glucose, fructose, galactose. Similarly, the examples for disaccharides are maltose, lactose, and sucrose. Whereas the complex carbohydrates are polysaccharides. They are starch, fibers, and glycogen. So what are monosaccharides? Monosaccharides are simple sugars, consist of one sugar unit that cannot be further broken down. That means the simplest form of the carbohydrate. Example: glucose, fructose, and galactose. Now, where are these glucose, fructose, and galactose available? Glucose is available in any sweet fruit, fructose in the fruits, and galactose right in the animals. Glucose comes from the Greek word for sweet. It's a type of sugar you get from foods you eat and your body uses it for energy. As it travels through your bloodstream to your cells, it's called blood glucose or blood sugar. Right, that is why we say that is in the case of diabetes when you go for testing. So they test your blood sugar level, your glucose level, right? Your BP is related with your glucose level. Blood pressure is related with your glucose level. How can we obtain glucose? First, we can obtain glucose from sucrose. Now, sucrose is obtained in cane sugar, right? Cane sugar means the long sticks, जिसे आप celery बोलते हो, right? Holy season mainly, this fruit is available in the holy season. So, if sucrose is boiled with dilute HCl or H2SO4 in alcoholic solution, glucose and fructose are obtained in equal amounts. Next, we can even obtain our glucose from starch, which is also termed as commercial production. So, commercially, glucose is obtained by hydrolysis of starch by boiling it with dilute H2SO4 at 393 Kelvin under pressure. Structure of glucose. Glucose, also called as aldohexose or dextrose, as glucose contains aldehyde group and it has a 6 carbon atoms with the hydroxyl group. It is known as aldohexose. Monomer of many of the larger carbohydrates, namely starch and cellulose, is present and act as a monomer. Most abundant Glucose acts as monomer for carbohydrates, namely starch and cellulose. Most abundant organic compound on earth is glucose. It was assigned this structure given below on the basis of the following evidences. Let's see its molecular formula. Its molecular formula is C6H12O6. Now, first of all, we need to conclude that glucose contains 6 carbon atoms. So, how did we concluded that? To show all the 6 carbon atoms are linked in a straight chain, glucose when reacted with HI, it produces N-hexane. This confirms that glucose contains 6 carbon atoms and they are linked in a straight chain. Second, to confirm the presence of carbonyl group in glucose. So glucose when treated with hydroxyl amine, that is NH2OH, it obtained as oxime. Similarly, when glucose undergoes reaction with HCN, that is hydrogen cyanide, it again produces the cyanohydrin product, which confirms the presence of carbonyl group in the glucose. To show that the carbonyl group present is an aldehyde group, glucose when treated with bromine water, it produced gluconic acid. I repeat, glucose when treated with bromine water, it produces gluconic acid. Next, to confirm the presence of hydroxyl group, that how did we come to know glucose contains 5 hydroxyl group? When glucose undergoes acetylation in presence of acetic anhydride, it obtains pentaacetate glucose, which confirms that glucose contains 5 hydroxyl group. To show the presence of a primary alcoholic group, now glucose, we have already proved that it contains 5 hydroxyl groups. Now, whether these hydroxyl groups are primary or secondary, that is proved by the reaction when glucose undergone oxidation, it obtains saccharic acid. Even gluconic acid when undergone oxidation, it again gave the saccharic acid, which shows the last group, that is CH2OH, that is present in glucose is a primary alcoholic group. Hence, after doing these all experiments and chemical reactions, the exact spatial arrangement of different hydroxyl group was given by Fischer, which is also known as Fischer projection formula, was given by Fischer after studying many other properties. Its configuration is correctly represented as structure 1. So gluconic acid is represented as structure 2 and saccharic acid as structure 3. Here we can see it has C6H12O6. That is, these all bonding are carbon. So 1, 2, 3, 4, 5 and 6 carbon atoms we have in glucose. Next, we are going to talk about D and L configuration. Now, what is D configuration and what are L configuration? This is not having any relation with the dextro or levorotatory. Now, when we say the D configuration means hydroxyl group is to be on the right hand side of your chiral carbon. I repeat, hydroxyl group to be on the right hand side of the chiral carbon, which termed as D configuration, and if hydroxyl group is there on the left hand side of the chiral carbon, it is known as L configuration, or else it is denoted as negative as well. Cyclic structure of glucose. Here we go with the cyclic structure of glucose. You can see the alpha D positive glucose and beta D again positive glucose. Now, in case of alpha glucose and beta glucose, you can see this carbon atom which is forming a ring structure, right? With oxygen, the hydroxyl group is on the different position. The cyclic structure of glucose is more correctly represented by Haworth structure as given below. Now, glucose is also known as glucopyranose because it is similar to the pyran, which is a heterocyclic compound. Pyrene is a heterocyclic compound, and as it is similar to a glucose, as it is similar to pyrene structure, it is also known as glucopyranose. Now you can see the alpha D positive glucose, that is hydroxyl group, is arranged lower the structure, whereas your hydroxyl group is on top of the structure. Next comes fructose. Fructose, also known as ketohexose, because here you can see the carbonyl group is a keto group, and as it contains 6 carbon atoms, so they are hexose. So fructose are also termed as ketohexose. Let's look into the structure of ketohexose. Right, it's a 5-membered ring which is similar to furan. Hence, fructose are also known as fructofuranones. Again, furan is a heterocyclic compound. The cyclic structure of 2 anomers of fructose are represented by the Hayward structure given as follows. Now, what are anomers? Anomers means, I will say, molecular formula, only they change in the position of the functional group. So, they are called as anomers. Mutarotation is the change in specific rotation of an optically active compound with time to an equilibrium value is called mutarotation. I repeat, mutarotation means the change in specific rotation of an optically active compound with time to an equilibrium value is called mutarotation. So alpha D glucose, it's having 112 degree. At equilibrium, it has positive 52.7 degree, whereas beta T glucose have the angle of rotation is 19 degree. Next, what are proteins? So proteins, as you know, that we obtain protein. These are the natural sources of protein to obtain. And protein is useful for the growth of your body, that is the muscles growth and repair as well. We have different structures of protein, different types of proteins based on its structure. So what are proteins? Proteins are the large biomolecules or macromolecules consisting of long chain of amino acids. I repeat, consisting of long chain of amino acid. Now this is our amino acid group, right? Carbon, this is the chiral carbon. It has one amino group and one carboxylic group. Hence it is known as amino acid. Now, amino acids are classified as essential, non-essential amino acids. Amino acids are classified on the different types, that is on the basis of synthesized and on the basis of availability. So we have different types of amino acids like essential amino acids, non-essential amino acids, and then on the basis of the strength, that is acidity, basicity, and neutral. So first of all, when we are talking about the essential amino acids, so essential amino acids are the amino acid that has to be obtained through diet, because it is not synthesized in the body. Hence, these acids are known as essential amino acids, and they few examples like valine, lysine, these comes under the essential amino acids. Next, non-essential amino acids. Now, non-essential amino acids are available, or we can say they are synthesized in the body, for example, glycine, alanine, etc. Now, when we are talking about the neutral amino acid, at that moment, the number of carboxylic acid group and amino group, they are equal in the structure, protein structure. Hence, those amino acids are known as neutral amino acids. For example, glycine, alanine, valine. Valine also comes under the essential amino acids. Even alanine comes under the non-essential amino acids. So we can say that essential as well as non-essential, can be neutral, can be acidic, can be basic. Okay. So acidic amino acids means the more acidic functional group. Example, aspartic acid, glutamic acid and asparagine. Whereas basic amino acid means amino group is more than the carboxylic group. Characteristics of amino acids tells us the uh, number of amino acids present in the group and how the amino acids have their acidity, basicity or neutrality character. So amino acids are basic units of protein. All amino acids have at least one carboxylic group and one basic amino group. Amino acids are colorless, crystalline solid. They are soluble in water and insoluble in organic solvent. So here comes the few list of natural amino acids that we obtain naturally with their abbreviation. That is, glycine is abbreviated as GLY, symbolized as capital G. Right, so you can see so many amino acids are available in nature. The list of amino acids on the basis of the classification as essential and non-essential. I told you the essential amino acid means which cannot be synthesized in the body, whereas non-essential amino acids are synthesized in the body. Properties of amino acid says that amino acid acts as Witter ion. Now what is Witter ion? When a compound has both acidic as well as basic nature, basic ions present in the given compound, they are called as Witter ion. Hence, a Witter ion is a molecule that has both positive and negative regions of charge. And the solid state amino acids exist as dipolar ions called Witter ions. The pH at which dipolar ion exists is neutral. I repeat, the pH at which the dipolar ion exists as neutral ion means positive and negative charge is equal and it does not migrate to any electrode. That point is known as isoelectric point. Except glycine, all other naturally occurring alpha amino acids are optically active because they contain chiral or symmetric carbon atom. They exist in both D and L nomenclature. Most naturally occurring alpha amino acids have L configuration. Different structures of protein, as I told you, we can classify proteins on the basis of their structures. The bond formed between two amino acids by the elimination of water molecule, that particular bond is known as peptide linkage or peptide bond. That is why it is known as peptide, because after the removal of water molecules, here you can see it is forming CONH, which is a peptide bond. Hence, n number of amino acids linked together by the removal of water molecules and result into a protein molecule. A series of amino acids joined by peptide bonds form a polypeptide chain, and each amino acid unit is a polypeptide, is called a residue. A polypeptide chain has polarity because its ends are different. Here you can see one end is amino group, that is NH3 plus, and another group end is carboxylate group, that is COO minus. Hence they are polar in nature. So classification of protein on the basis of structure is fibrous protein, globular protein, intermediate protein. On the other hand, if protein is classified on the base of its composition, they are simple protein, conjugated protein, and simple protein is also termed, also classified as like albumins, globulins, histones, and scleroprotein. whereas conjugated proteins are your phosphoprotein, glycoprotein, nucleoprotein, chromoprotein, lipoprotein, flavoprotein. Now, knowing these proteins, now you might be wondering that this nucleoprotein, chromo means color, right? The proteins, है ना? जब हमारे hair white color के हो जाते हैं या हमारे pigment, so these all are due to the protein. Hence, we need to consume more of protein in our diet so that our skin, our health remains healthy and we look good. So here comes the primary structure of protein. The primary structure of protein here, you can see that we have alpha helix and we have beta pleated structure, right? But what is the difference between the alpha helix and beta pleated? You can see the primary structure, it is a linear chain, right? So at one end, carboxylic acid group is there, and at another end, amino group is there. Whereas we will find changes in the secondary structure, that is at alpha helix and beta helix. Now what changes do you find? So here we find the linkage between the number of carbon atom, that is CONH. Right, kindly count the number of carbon atoms, that is every fourth carbon atom of the chain, of the spiral chain, is linked with the other four, right? 1, 2, 3 and 4. They are 4, 5, 6, 7. So they are linked in that manner. So that is our alpha helix, whereas beta helix means it is interlinked with the two regular chain. So here comes the diagrammatic representations of protein structure. That is, we have primary, secondary, tertiary and quaternary structure. Next, denaturation of protein. Denaturation means disturbance created in the structure of protein. A simple meaning, disturbance created in the structure of protein, that is called as denaturation of proteins. So when protein is in its native form, it is subjected to physical changes like change in temperature or chemical changes like change in pH. The hydrogen bonds get disturbed. Due to this, globules unfold and helix gets uncoiled and protein loses its biological activity. This is called denaturation of protein. Denaturation causes change in secondary and tertiary structure, but primary structure remains intact. Coagulation of, for example, what is denaturation of protein? So in daily life, you can see this example, coagulation of egg white on boiling, right? When you boil your egg, the white part, liquid part, it gets converted into coagulation, means that becomes thick and strong. It remains soft, but it is now in the semi-solid form. Then curdling of milk, formation of cheese, and when an acid is added to the milk, it converts into the paneer. So these all are the examples of denaturation of proteins. Next, what are nucleic acids? So the full form, nucleic acids, basically DNA and RNA, they are the molecules responsible for carrying the genetic information of a cell. In the same way that proteins are polymers of amino acids, so nucleic acids are long chain polymers of nucleotide building blocks. You can see here double spiral structure, right? We also call it as a double helical structure given by Watson and Crick. We have different types of nucleic acids, that are deoxyribonucleic acid, DNA, and ribonucleic acid, which is known as RNA. Now, RNA, on the basis of its function, it is again classified into three different types. That is messenger RNA, which is also known as mRNA, ribosomal RNA, which is also known as rRNA, and transfer RNA, which is known as tRNA. Now, what is this Chargaff's rule? Chargaff's rule states that DNA from any cell of any organism should have at least 1:1 stoichiometric ratio of pyrimidine and purine bases, and more specifically that the amount of guanine should be equal to cytosine and the amount of adenine should be equal to thymine. This pattern is found in both strands of the DNA. Here you can see that guanine to cytosine G to C, A to T, T to A. Right. So what is this T? T stands for thymine, A stands for adenine, G stands for guanine, and C stands for cytosine. Replication. It is the process by which a single DNA molecule produces two identical copies of itself. That is known as replication. What is protein synthesis? How do we do so? We have already learned in our lower grade that endoplasmic reticulum helps to undergo protein synthesis. Right. So here we will see that protein synthesis occurs in two steps. First is transcription and second is translation. Transcription means the process of synthesis of RNA, that is ribonucleic acid. Whereas translation means the protein synthesis of protein occurs in the cytoplasm of the cell. mRNA directs protein synthesis with the help of rRNA and tRNA. Thank you. Have a nice day.